Hey guys, so I wanted to take a couple of minutes and just go through the study guide just in case you missed it, or maybe our class just didn't have enough time to go to certain problems. I just wanted to make sure that you had all the information you needed. So the first category that we have on the test coming up is we're going to have evaluating from an equation. So this is where we take our value, and let me change my color. We're going to take our value, our x value, which in this case is a -8, and we're going to ask ourselves, in which constraint does this fit? If I plug it in right here where this x is -8 less than -2? And that's actually a true statement, so I don't even have to continue any further. I know that I'm going to be using this equation 3, and I want to plug in a -8 into an x value, but as we can tell right here, there's actually no x value. So my answer is just 3. And I just keep doing that. So now I have 0. I'm working downwards, not sideways. 0, I ask myself, is it less than -2? That's not a true statement. Is it between -2 and +5? That is a true statement. So I'm using this equation, x plus 2. I take my x value, I plug it into the x. So it'd be 0 plus 2, which equals 2. F of 5. So even though 5 is in both locations here, I have x is less than or equal to 5 here. And because it says equal to, I know that this 5 actually has to fits within this constraint. So therefore I should use this equation. And so 5 plus 2 gives me 7. -2, again, same exact scenario. We have two -2s. This one says less than, but this one says less than or equal to. That equal to part is what I need. So I, again, am using this particular equation. -2 plus 2 is a 0. 3, again, fits within the -2 and 5 constraint. So it's going to be 3 plus 2, which is 5. And then finally, my last one, this is f of 10. This is no longer between -2 and 5. It's actually bigger than 5. So I plug it in. Notice I have my x value. I plug it in there and I get 40. Okay, so that's the first thing you're going to see. The second thing you're going to see is the same exact idea, but now we're going to be evaluating from a graph. So think about this as an ordered pair. Again, they're giving us our x values within this parentheses, and we're going over to the graph and asking ourselves, well, what is the y value if our x value is -2? So let's look at that. -2 is here on the x-axis, and I do have a open dot above -2, and I have a closed dot below -2. Now, if it's an open dot, I actually ignore that because an open dot means it cannot equal that particular number. So I can just ignore this, to be honest. However, if I go below, I have a solid dot. That means it can equal this. A solid dot is like a line, right? It's like a line right here. So imagine that this is a solid dot, but then so again are all of these points along this parabola, which is what this shape is. So I have -2. Here is my solid dot, which is what I want to look at. Again, I'm ignoring that x value up here, so let me just sort of let me back up, Control Z. Let's just cross that off so we can sort of ignore it for a second. So here's my -2. I care about this solid dot here. And so if I write this ordered pair is -2, comma, -4. So again, I already know my x value. I know my x value because that's what they gave me over here. The question is, what is my output? If my input is -2, my output would be -4. And that's how you solve this for all of these problems. So -1, here we are, -1. There's nothing above it. It's just blank. But there is something below it. There's actually a line, and a line is like a solid dot. So the ordered pair right here is -1, -1. So my answer is -1. F of 0, same idea. Nothing above it, but there is a point already here. My y value, my ordered pair here, is 0, 0. So my answer is 0, 0. Or 0, excuse me. Then I have f of 2. I have a solid dot here, so I know I should use this. But let's just look down here just to double check. I do have an open dot, and I said to ignore all those open dots. So we'll just cross that off. We don't need that. We need this, and the order pair here is 2, 0. So once again, my answer is 0. And then finally, we have f of 2. F of 2 is going to be right here along the x-axis. There's nothing below it, but there is something above it. The order pair here is 4, 2. And so my answer is 2. All right, then we come to graphing. Graphing, the first thing you need to do is double check your constraint number. My constraint number is with my inequality over here. Sometimes I have 1, sometimes I have 2. So I am going to, I only have one number, so I'm going to draw a dotted line on this number. This is my constraint line, right? This is like where I would cut my graph into pieces, okay? So I only want one piece on the right and the other piece on the left, but they can't cross over. So on the left-hand side, and I know it's going to be the left-hand side because notice that my inequality symbol, I'll change the color. My inequality symbol here, it like creates the head of an arrow and it's pointing to the left. So I know that all my information is going to be left of my constraint number. Okay, so I am going to create a XY chart to find my information. The first number I need to pick is the 2, what is happening on the constraint line. And then the other point, it can be any number that's less than 2. So I'm just going to pick 1. I could pick 0, I could pick -1, but it's just easier to do 1. And then to find my outputs, my Y values, I'm taking my formula and I'm plugging in the X values that I found over here on the left. So this is going to be -2, and this will be -1. So now I have my order pairs. I can plot my points. I've got a point at 2, -2, and I've got a point at 1, -1. And once you have 2 points, usually what I do is I take like a ruler or like a lanyard or something straight, and I just connect the dots, extend it a little bit, and I add my arrowhead. And I want to point out that notice that my arrowhead is not over here on the right. It's on the left-hand side because my arrow is pointing to the left. So it doesn't matter if it's going up or if it's going down, as long as your arrow is on the left-hand side, you're fine. So same idea with this one over here. It doesn't matter if I draw my picture up and to the right or down and to the right, as long as it's to the right, okay? So now I'm going to do the XY chart for the other one. XY, I start with my constraint number 2, and then any number that's bigger than 2 would be 3, 4, 5, 6, 7, or 8, which I'm just going to do 3. I plug that in to my new equation, which is x minus 6, so it would be 2 minus 6, which is -4, and 3 minus 6, which is -3. So I have an order pair at 2, -4, which is going to be here, and I have a point at 3, -3, which is here. So I connect my dots, and there we go. The final thing I need to do is just take a moment and double check that you have the correct dots on the constraint line. I cannot emphasize this enough. It can't be on this line or this line. It needs to be on the constraint line, the one that is highlighted right now. So I'm a little lazy. Remember, if you have just I'll put it over here. If you have less than or greater than, it's going to be an open dot. But if it's a less than or equal to, or a greater than or equal to, it's going to be a closed dot, and it's based off of, you can't see that at all. It's based off of this little line underneath, that equal to. They're saying it is allowed to equal this. So if I look at my constraints, the first one says x is less than 2, so that's an open dot. And the other one says x is greater than or equal to, so that would be filled in. So the arrow pointing to the left, that's what this one over here, this should be an open dot. So I'm lazy, so I'm just going to draw a big open dot on top of it, and I'm going to be done with it. Okay? So that's how you graph. So the next thing that we're going to do is, it's still graphing, but it's a multiple choice. So you are taking your equation that we have over here on the left, and we're matching it to the options that they gave us here. Now there's 3 strategies or 3 things to check when it comes to this. The first one is our information on the correct constraint number? So my constraint number is 1, and so if I come over here, I can say, all right, is where I cut my lines on 1? Well, on this letter A, it is. Over here on letter B, it is. It's all on 1. On letter C, though, it actually jumps over to -1, and so that is not what I want, and so I can actually cross off letter C. Same thing with letter D. Again, it's over on the -1, And even though they're ones, they're not the same value. 1 does not equal -1. So we can go ahead and cross these out, and now we're just left with an A or a B, which is really nice. That's the whole purpose of this, to have our process of elimination. So the first thing that you're checking is your constraint line, or your constraint number, constraint line. The second thing I would like you guys to check are your dots. All right, so remember what I said. The first one is to the left, right? And it doesn't have that equal to part, so it's going to be an open dot. So I don't actually care what's happening in like A and B. I don't actually care what if it, like, this is on this side. I'm not actually calculating anything right now. What I'm just checking is if I have a constraint line here, on the left hand side, is there an open dot on that line? Okay, so let me go back, and I can actually see right here that left of the constraint line, this is a solid dot, which according to this needs to be open. So I can actually cross off A, and I'm left with B as my answer. Okay, and we're going to do one more because I want to show you the third strategy really fast. And that third strategy is going to be when we calculate. So here's the new problem. All right. My constraint number is fine, and if I take a moment and look at my dots, I know that the -7 is going to be a closed dot because of that equal to part, right? And on the 3 is going to be an open dot. So between -7 and +3, it should be a solid on the left and a open on the right. So A works out so far. I go to B, it is open on the -7, so that doesn't work. On C, it is in fact a closed dot, and then on the 3, it's an open dot, so that one's good. And then finally, our last one, letter D, if I look at -7, it is open, and so therefore that one does not work. I'm going to make it a little bit darker so we can really make sure we don't look at that anymore. All right, so I'm left with either A or C. I mean, I could take a moment, I could, take a guess if I really wanted to, but the third strategy you can actually use is to go ahead and calculate it, okay? So I know what the equation was to create this line, and I can take either the -7 or the 3, or really I can take any of the values in between, which I don't want to. It's just easier to do the -7 and the 3. One of the numbers that are here, essentially. So I'm going to take 3 because I don't feel like dealing with a negative number. So if I plug in a 3 into the x, right, that'll give me 3 plus 3, which is equal to 6. So my input was 3, my x value was 3, and then my output was 6. So I'm going to double check my inequality, or my ordered pairs that they gave me that are right here on the constraint line. I have one that is 3, 6 and one that is 3, 7. And according to my calculations, it should be 3, 6. So I can actually cross off letter C because it doesn't actually work. The dots are fine, everything was good on that end, but because the calculation was wrong, it's not correct. And so that is our answer for this one. All right. You'll have another one that's similar to this, except instead of you matching the graph to your equation, now you're matching your equation to the graph. So again, the same strategies that we had before are in play. So for example, if I look at option A, it says that to the left of my constraint line, right? Let me change my color. To the left of my constraint line should be a closed dot. So here's my constraint line, and I can see that the information to the left is this one right here, is this equation, and it's an open dot. So I can actually cross off A because automatically I can tell it doesn't work. If I keep going, this is to the left and it's open, so we know that one's good. This one's to the left and it's open, so again, that one's good. B and C are both possible. Now let's do some calculations because the constraint line, obviously everything's on 1, so that's not an issue. So I'm going to do my calculations, and I'm actually going to plug in a 1. So I'm going to take this first one, and I want to see what does it do. I have 1/2 of 1 plus 1. Well, that's going to give me 1.5. So I should have an order pair at 1, 1.5. And I don't see that here or here. So obviously B is not going to work. And so once again, just by process of elimination, I've been able to figure out that this time our answer is C. So it's very similar, it's all along the same lines, and hopefully that helps you on the test tomorrow. So then we go to graphing with a word problem. So I'm going to give you a couple seconds just to read this. I'm going to read it out loud just to make sure we've got this. But it says, Mrs. Dix, which is me, is trying to get into shape, and so she runs 10 laps around a track. Her first 2 laps, she averaged 3 minutes each. So each lap took her 3 minutes, all right? So the first lap took her 3 minutes. The second lap took her 3 minutes. Her next 2 laps, she averaged 5 minutes per lap. So that means lap 3 was 5 minutes, and then lap 4 was also 5 minutes. The next 2 laps, she averaged 7 minutes each. Finally, on lap 7, she gave up on running due to an old injury, and she walked at a pace of 10 minutes per lap. So the last lap 7, 8, 9, and 10, I just started walking, and it took me 10 minutes for each lap because apparently I'm really, really slow, but it's fine. All right, so then the last part says, graph the scenario where X is your lap number and Y is how long Mrs. Dix has been on the track, which, again, that's me. So I'm going to actually, since we're dealing with a real-life scenario here, I'm only going to deal with positive numbers. So I only care about the first quadrant because that's where all the positive numbers are. And what I'm going to do to sort of help organize my information is I'm going to create an XY chart. So I'm going to put my, according to the previous one, they say that the x-axis should be the lap number, right? So this would be 1, this would be 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, so I'll do by 2s. 2, 4, 6, 8, and 10. All right. So off to the side, I'm going to help myself, and I'm just going to put what lap number I have, and then we'll calculate the rest. Hold on. 7, 8, 9, and 10. All right. So this is my lap number. And then the question was, for the y-axis, I should say, it said, how long has Miss Dix been exercising? Apparently I can't draw straight. Oh my goodness. Struggle is real, guys. Hold on. Oh, still terrible. Yeah, I did it. Awesome. Okay. So the y-axis is supposed to be the time that I'm taking to exercise. Like how long have I been on the track? So we'll actually put, we'll put time on the track. And because I have limited space, I'm actually going to go by 5s. So I'm going to say, I'll just label the 10s though. 20, 30, 40, 50, 60, 70, and 80. All right, there we go. So all this extra information on the right-hand side I don't actually need, but the first thing I'm going to do is I'm going to look at my question, which I've already gotten rid of, but it said that the first 2 laps took me 3 minutes. So my first lap took me 3 minutes, right? And then the second lap, it took me 3 more minutes. So how long have I been exercising at this point? Well, if each lap is 3 minutes and I've done 2 laps, that means 3 plus 3 is 6. Then I say, then the problem says the next 2 laps, so that's lap 3 and lap 4, the next 2 laps are 5 minutes apiece. So if I've already been exercising for 6 minutes, right, after lap 2, and I add an additional 5 minutes for lap 3, and then an additional 5 minutes for lap 4, well, now I'm at 16 minutes, okay? Then they say the next 2 laps are 7 minutes apiece, because I'm slowing down, I'm getting tired. So 16 plus 7 gives me 23, and then 23 plus 7 gives me 30, because now each lap takes 7 minutes for me to complete. Then it said that around lap 7, which is perfect because now I'm on lap 7, right? Lap 7, I just gave up. I'm not doing that running thing anymore. I'm going to walk. I have an old injury. So I give up on walking on lap 6 after 30 minutes of running. So now I walk at a very leisurely pace of 10 minutes per lap. So even though I'm going at a constant rate of 10 minutes per, I am adding that 10 minutes to how long I've already been exercising. I've already been exercising for 30 minutes. So lap 8 will be 50 minutes, lap the 50th minute of exercising, if you will. Lap 9 will be the 60th minute of exercising, if you will. And then finally, lap 10 will be the 70th. So now that I have all of my X values, and my X and Y values, I can go ahead and start plotting. So it should look something like this. We got 1, 3. We have 2, 6. We have 3, 11. 4, 16. 5, 23, 6, 30, 7, 40, 8, 50, 9, 60, and 10, 70. All right. And once I have these points, I can go ahead and sort of connect my dots. Like these are all connected to each other. This is a constant rate between these values here. And then these two are connected, these two are connected, these two are connected. All right, so I've sort of created this graph. It's beautiful. Once you have this written down, we can actually go ahead and answer some of the questions. So let's get rid of the screen and go to the questions. One of the questions I could ask on the test is, how long did it take Mrs. Dix to complete 10 laps? Well, as you could tell, in the 70th minute, that's when I ended. All right, so it took me 70 minutes to do a lap. Please make sure you include a unit, otherwise I will like fill in some random thing like gophers or something and be like, why do I have 70 gophers? Why are we talking about gophers when you should be talking about time? But anyway, so please make sure that you include your units. How long did it take for Mrs. Dix to give up and start walking? Well, remember, I gave up after the 6th lap, and the 6th lap, I finished that after 30 minutes of exercise. So the answer for that is 30 minutes, lap number 6. What lap was Mrs. Dix on an hour into her running? Well, 60 minutes is an hour, and I was on lap 9. It took me an hour to run 9 laps, which is pathetic. For the record, this is not a true story. I'm a little bit better than this. It's not much better, but I'm a little bit better. Okay. Last one. Seth got a job at Witt's Frozen Custard and tracked the number of cones sold during each day of his shift that first week. This is very similar to what you're going to have on your side for the test, where we have a lot of questions. Notice that A and B are like part A, part B, and then letter C is which of the statements are true, and so this is like a select all. So I don't want you to think that you read the question and then you just circle A. Like that, it's not a multiple choice. It is part A, part B, part C. So make sure that you take your time on this one. But it says Seth got a job at Frozen Custard, tracked the number of ice cream cones sold during each day of his shift that first week. And so all that information is here. So notice it says Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday. How many cones did he sell his first week? Well, on Tuesday he sold 70. And on Wednesday, he sold 60. Okay, so that's a total of 130. So I'm actually going to have to add everything up. So let me get a calculator. It's going to be 70 plus 60 plus 90 plus 60 plus 100 plus 100. It would help if I actually put 100 into the calculator. And then finally on the last day of the week, I only sold 50. And so my answer would be 530 ice cream cones. So I'll say 530 ice cream cones. All right. Which days did he have a decrease in selling cones? Now this one I want to make sure that we understand. I want you to write it like an interval. So like notice over here that he did decrease these 2 days. So we're going to write it as Tuesday to Wednesday. So I'll say Tuesday to Wednesday. All right. He also decreased from Thursday to Friday. So I'll say Thursday to Friday. And then finally, the last day he actually decreased was from Sunday to Monday. So we actually have a couple of answers here, but when you write it, I need you to write it like an interval from this date to this date, or depending on the type of problem you have on the test, like from this time to that time, okay? And then finally, we come to the last little bit, which is select all that apply. So Seth had a negative rate of change from Tuesday to Wednesday. So Tuesday to Wednesday, it does in fact go down. So this is a true statement. Seth had a negative rate of change from Tuesday to Thursday. To Thursday. Well, it does go down on the first day, but then it goes up on the second day. So this is actually not a true statement, because it would have to say something along the lines of like Seth had a negative rate of change and then a positive from Tuesday to Thursday, and they only say negative, so it's not a true statement. Seth had a constant rate of change from Saturday to Sunday. Well, it does in fact stay the same. That's what constant means, so that's a true statement. And then finally, Seth increased the number of cones he sold by 50 from Sunday to Monday. So here, Sunday to Monday, it goes from 100 down to 50. And they said increased. Well, it is by 50, but it's not increasing. It is decreasing. Oops, did not mean to do that. So this is actually a false statement. Okay, so that's very similar to what you're going to have on the test. I hope that helps you. I know some of you guys were really worried about those word problems, but if you are using this and the Kahoots to study, then you should be good to go. All right, good luck. And if you have any questions, be sure to email me.